Good afternoon, everyone. You're welcome to this DVB webinar dedicated to one essential piece of the DVB's new IP-centric solutions, and this is the DVB native IP. This webinar will mainly give you some clues about why the industry considers embracing native IP media distribution formats as a new generation broadcast solution. I am Emily Dubs, DVB's head of technology, and I'm really excited to moderate this webinar and also to introduce the topic as well. I will indeed provide you first with some context, especially about where this solution stands in the new IP-centric ecosystem. And after that, I'll be pleased to welcome some of our experts in the field who will first review the many reasons why a native IP standard is necessary. So this first part will be presented by Lhermitte, CTO at ENENSYS, and together with Thomas Wrede, who is on behalf of SES, the chair of the DVB commercial group that developed the requirements for the solution. Next, Jean-Claude Sachot, who is business development director at Broadpeak, will give an overview of the early market perspectives. And finally, Thomas will be back to tell us about the native IP journey within DVB. That means what is being currently done and what's the timelines for that. So great thanks to all of them for their good collaboration. And before I start, I'd like to remind you that you have the opportunity to ask questions. So please do so using the question box at the bottom of your screen. And we'll deal with them at the end of the session. And for us to better organize this Q&A session, please post your questions as we go along. So first, I'm sure that you'd be happy to be provided with some context and understand where this solution stands within the DVB new IP-centric ecosystem. I'm also quite sure that you would agree that the discussion in the media industry has totally moved from distribution to service. I mean, if you remember, DVB has been initially created for the standardization of digital media distribution as a replacement of analog TV. And then DVB also enabled the transition from SD to HD, which were both, of course, great achievements. But now DVB is shifting its focus to a whole new direction with a new mandate, which is to help the industry tackle a transition from fragmented industries evolving in their own silos to unified ones that would enable seamless experiences for the users. And that goes along with a move also from purely broadcast to hybrid and ultimately IP networks. So today, it's mainly a matter of service. How does a user can simply retrieve the relevant services among thousands, no matter how it is transmitted and no matter the device being used. So DVB has acknowledged that shift in terms of challenge, and it's now focusing to create the required solutions for those real new needs. And DVB's new IP-centric ecosystems offers that solution. It mainly builds on the DVB-I package, which at the core includes DVB-I service discovery. So this solves the problem of fragmentation by offering an harmonization at the service layer. And this is thanks to a unified metadata delivered over the internet. In addition, DVB-I also defines the service delivery over the internet by referencing the DVB dash. So it's an optimized streaming format, and I'm sure you know that it also exists on its own. So it's part of the DVB-I package and exists on its own. And DVB-I also builds on other important blocks, for instance, the DVB MABR one, which is a way to enrich unmanaged networks with the scalability and thus the reliability of broadcasts. And another important one is the TA specifications that offers new opportunity for broadcasters thanks to more impactful advertising campaigns. And this is especially the case when it's used in combination with the HbbTV specs. And by the way, if you'd like to know more about this, we had a webinar last month that you can watch now on the DVB website. So now, if we deeper dive into this harmonized service layer, which is the core of the DVB-I concept, we better understand how it breaks down the barriers between the broadcast and the broadband worlds from the user point of view, because it offers a means to integrate all kinds of services in a unified service layer that will ensure that whether services come from broadband, so for instance, using DVB- or other formats, or even 5G broadcast bearer, for instance, or whether it comes from broadcast, it really doesn't matter. And thanks to this harmonized metadata, the user can access services in a consistent way, regardless also of whether they are using a TV set or a smartphone. So that's why I like to say that this really makes fragmentation seamless. And that's not all, and this is especially where the new native IP solution comes in. It's a kind of transition tool within the transition toolset. That's DVB's Swiss Army knife, I would say. You will see that DVB-I will also allow the discovery of media content that is normally distributed over IP networks, but that is transmitted over broadcasts. And this, even though it's using OTT packaging formats. And this will be made possible thanks to the new native IP solution that is referencing and profiling some of the existing DVB specifications. So I'll now, of course, let my colleagues tell you why all this took shape. And I'm very pleased to introduce Thomas Wrede, who will speak first. He has 35 years of experience in this industry. He has been deeply involved in the development of digital satellite television, especially within SES. And even if he's now also the founder of his own consulting company, today Thomas continues to represent SES in the DVB commercial module. He chairs the CMS subgroup, which is the group that defines the commercial requirements. So that way he will give you the context and also outline some of the use cases. And he will then later be joined by Richard Lhermitte, who is CTO at ENENSYS. He has 25 years of experience in our industry through various roles, and he is also an active participant in the DVB working groups. So great thanks to both of you, and now over to you, Thomas.
Right. Thank you very much, Emily, and good morning, good afternoon, good evening, wherever you are, ladies and gentlemen. Thanks for taking the time to attend this session. And I'd like to thank Emily a lot for the introduction, of course, but also for arranging this webinar, push us to put the content together and give you an introduction about native IP. So first, let me set the scene for native IP a little bit. We all know that since years, internet-connected TV sets, referred to as smart TVs, PCs, tablets, and of course mobile phones are ubiquitous in our consumer homes worldwide. And all of these devices are OTT enabled. And also we know that today's consumers ideally want to access both linear and non-linear content on multiple devices. So that's something that a need, a standard or technology should fulfill. So trying to move my, okay. Viewers are leveraging both on-demand streaming and linear TV to optimize their viewing experience. But with all the success of the big streaming providers, one thing is clear though, linear television consumption is remaining strong. And we heard that it even significantly increased during the COVID-19 pandemic, as consumers just love to watch those big live sports, entertainment, and game shows. So also using the browser, and that is referred to here as browser fatigue, has some limitations and bears some inconvenience, while also consumers always fall back to linear television. So you may say that, well, broadband can transport linear and non-linear television. And technically, yes, that's absolutely correct. And many of us here in Western Europe, in the big hubs in Asia or North America, watch linear TV on their high-speed internet or fiber connection. But it is only correct for specific countries and markets, which is a bit explained and outlined on the slide you're just seeing here. So consumer access to high-speed broadband is often very uneven. And that's also, of course, thinking about satellites, a reason for the ambitious plans of Kuiper, Starlink, and other satellite broadband connectivity providers. So broadcast always has simply the reach and signal availability that broadband doesn't yet have, at least not in all world markets. And broadcast, hence, is the ideal technology to deliver educational content to remote areas, for example, feed terrestrial transmitters, 5G cell towers in emerging markets, deliver linear video content to community Wi-Fi access points, and take video content also to aeronautical, maritime, and mobile locations. So when it comes to native IP, with native IP, we refer to video consumption through connected devices. So through smartphones, tablets, connected TVs, Android set-top boxes, and so on, and a way to reach those new screens, as well as traditional television screens. And the traditional broadcast transport format, the MPOC TS, is not necessarily tailored for those IP devices in the market. The DVB project wants to develop a new standard that is built on the most modern technology and on its building blocks, as Emily had mentioned them, like DVB GSE, MABR, DVB-I, DVB-, just to name the most relevant. And the requirement for delivering and developing a native IP standard has been strongly supported by the satellite operators initially. And that's the reason that as chair of CMS, I got the task with my team to develop the commercial requirements for native IP. But let me say already here that the use cases for native IP, of course, are equally applicable to a native, to a terrestrial transmission system. So what is the vision for the future video delivery? Today we reach linear, with linear MPEG transport stream video, the smart TVs, we reach the set-top boxes of operators or free-to-air set-top boxes. But as it is shown here, that is where it stops. We reach the big TV screen, fine, that's what broadcast wants, but we don't reach all the IP-enabled devices. And I remember working at SES and at the 2010-11 timeframe when all these IP devices came up. We scratched our heads and started to develop what we called SAT2IP. So a technology that required a set-top box, a converter from transport stream to IP, that required applications, different applications for different devices. It was rather complex, but we managed to get linear broadcast onto these tablets. But the world has moved on since then, and the vision for, let's call it tomorrow, is for a file-based IP delivered video system, where we reach what satellite in this use case here, in this example, reaches already today, the IDTVs, the set-top boxes, but we also want to reach with one and the same transmission technology, also IP gateways. IP gateways that are connected to IP players, that reach media sticks, that then are connected via HDMI to the TV set. But we also want to reach tablet phones, PCs that are connected to the IP gateway in the home. And at the same time, yes, that system shall also serve to feed terrestrial television towers or 5G towers, or reach mobile maritime aeronautical locations, and then via Wi-Fi take linear broadcast content to tablets, phones, PCs, to IP-enabled television sets, and of course allow for both linear and non-linear TV content watching. So that is the vision for native IP, for the native IP standard. So as you know, for DVB, it is always essential to start from commercial requirements. That is at the heart of the DVB topology, of the DVB thinking. We first think about use cases, about commercial need, about commercial requirements. We formulate those requirements, and then we move on to develop a technical standard. That is absolutely in the DNA of DVB. So use cases usually start the discussion about commercial requirements. For native IP, we started with B2B applications because it clearly dawned to us that that would be the first use cases applicable to a native IP standard. So one, of course, and I've mentioned it on the previous slide, is the mobile edge feeding to 5G cell towers. So where we extend the reach of the OTT headend via a satellite uplink, have the native IP stream delivered via, for example, one or several geostationary satellites, and then reach a native IP client and deliver the OTT chunks, the content to the 5G mobile edge. And then there it is bundled with the other 5G traffic reaching the 5G tower, enabling a 5G broadcast. And as I indicated earlier, the same topology is obviously also capable of delivering content to terrestrial transmitter towers. Another use case, and that is strongly driven by the satellite operators, is reaching Wi-Fi hotspot in remote areas and in emerging markets. And that has the capability to deliver content to Wi-Fi hotspots in schools, in restaurants, and in public spaces, and enable viewers to log onto the system, watch a linear movie show, a linear sports event on their own smartphone or tablet. But also such use case is applicable for industrial type use cases. So if we want to reach oil, gas rigs, remote learning in emerging markets, that's where we did some early tests actually at the SES, taking content, learning content, distance learning content via a, let's call it predecessor of native IP to schools in South Africa, for example. And this concept can be adapted to all sites that have no terrestrial connectivity, or that have no good, no high broadband, high speed terrestrial connectivity. So those are the use cases. Another use case, and that is also relevant, is a use case where we have a classical visa terminal. And that is, again, the classical domain of the satellite operators. A visa terminal that is reached via LEO, MEO, or GEO satellites. And by using a native IP technology, we can reach, again, from the OTT head end, we can reach via the VSAT hub and gateway, the terminal, on an airplane, on a ship, or again, on an oil and gas rig. and we reach the native IP client and deliver the content, the OTT chunks, to the wireless local area network, and then use the mobile devices to reach the end users. So if you want, this is a classical B2B2C use case. And it's very relevant, as I said, for the satellite operators, but also for the manufacturers that are active in the areas of VSAT terminals and respective hub and gateway equipment. And this use case serves the aeronautical, maritime, mobile, enterprise, and the educational sector. Right. So with this short overview of why native IP and what use cases for B2B applications are, I'd like to hand over to Richard for starting with the use cases for B2C applications.
Thanks a lot, Thomas, for this very nice introduction about DVB NIP and this B2C presentation. I will now focus mostly on the B2C application and some examples which have been worked on the DVB CM group. Of course, the first B2C application that we are thinking about is the possibility to make directly the content available at home using what is called the home gateway. So the DVB NIP is the possibility to take the OTT content, broadband content, to deliver them over the broadcast network. And as you said, Thomas, it can be satellite, terrestrial, but any kind of broadcast network. And to provide this OTT chunk to a home gateway, which will be able to make like some local edge caching, and any devices at home will be able to get this content locally using the Wi-Fi or the Ethernet cable at home. So any, let's say, pure IP player, which could be on a PC, on a tablet, on a smart TV, will be able to grab this content from this home gateway and display it. So that's an easy way to provide the broadcast feed to any kind of devices at home, which are not necessarily having a broadcast connection or direct antenna connection or satellite connection, but which have the IP connection to your home gateway and will receive the same content as what is available for everybody. On this example, the return path is used mostly to be able to provide additional information or to get access to some, let's say, on-demand content that I will explain later on. But also, if the content is protected, we are using this return path just with a few amount of boundaries to be able to get the DRM access and so on. So that's, let's say, the classical and easy first use case for B2C. On the broadcaster side, the very interesting point, and that's the case for the other B2C application, is that the broadcaster will use only one, let's say, headend, which will create the content for the OTT broadband world, but also for this broadcast NIP world. So only one headend, which will provide the same content over the different networks. That's a huge impact on the broadcaster, let's say, architecture. It will have to handle only one kind of content for any kind of network. The same use case can be also available, but without a return path at home. This is the goal of the DVB NIP, is to be able to provide such technology with no return path for some country or from area which have a very poor network of broadband connection. And as you said, Thomas, there are a lot of parts in the world where the broadband connection is not very good, and sometimes the connection is not or available at all. So DVB NIP allows this possibility to access and to provide the content, even if for it's a PC, a mobile, or a smart TV, for this content to non-connected devices without internet connection. And what is also inside DVB NIP, as you said previously, Thomas, that it's also using a file delivery system. We are able to push any kind of file from this broadcast headend to the receiver side. And typically, the electronic service guide or any other file that you want to push could be also provided to the end user devices. And typically, the DVB-I information can be pushed to be able for the receiver at home without an internet connection to have the list of the services and all the related content to these services. Another use case which is interesting is the merging and convergence of the broadcast and broadband. As we said previously, DVB NIP is mostly something like OTT over multicast and over broadcast. And the consumer electronic device can receive exactly the same content using this broadcast network, but also using the broadband network. It doesn't care on the receiver side if this content is coming from one network or another. And that's very interesting. Typically, for the broadcaster, it can create a bouquet of service. Some of these service will be delivered over broadcast. Some of them will be delivered only over broadband. On the receiver side, there is no difference. You will access to one service or another one without knowing where the content is coming from. Another example is you have a tablet and you are at home, you receive your content using the Wi-Fi at home, and this is the content you want to watch while you are moving. And you go out to the home, you have a, let's say, 4G, 5G network. You continue to watch your content using the 4G, 5G network, accessing to this OTT content. And while you are back to your car, for example, we could imagine to have inside the car not a home gateway, but a car gateway, which will receive the same content over broadcast and deliver inside a small Wi-Fi in the car. And you will continue to watch the same content in the car, just using a tablet, having an OTT broadband player, an IP player. So that's very interesting for the broadcaster to know that at any place he can provide the content without knowing on which network he will deliver it. Of course, another interesting things when we think about broadcast and broadband convergence is that we could enrich the broadcast service using some content coming from the broadband network. Typically, if you have a service with different languages, you have English, Spanish, French, and you have, I don't know, a very non-popular language, you don't want to broadcast this non-popular language, a local language, but you can provide this language using the broadband connection. On the receiver side, it will receive the video using the broadcast link and this specific language using the broadband, and the mix will be done on the receiver side. So that's a way for the broadcaster to provide more content using the different way to deliver it. We could also imagine to make scalable video encoding. On the broadcast side, you will deliver the HD layer, for example, and if the receiver has a broadband connection, it will access to the additional layer of the content to be able to upscale from HD to 4K using scalable video encoding. So part of the video, 4K video, will be delivered over broadcast, and the second part will be delivered over broadband. That's one possibility. And last, we could imagine easily that while you are using the broadcast mechanisms to deliver linear TV, we could enrich this content using on-demand content on the same screen, because the player is exactly the same. It's a native IP dash player that will receive the live feed and on-demand feed. So the broadcaster can easily mix any kind of content for the end user. The other application that we are thinking is, due to the fact that it's mostly OTT over broadcast, all the targeted tools, advertising tools that are available on the broadband world can be reused easily on this broadcast system. And this targeted ad insertion will be done on the receiver side. So the broadcast of the linear feed will be done with traditional network, and on the receiver side, the capability to switch from broadcast to broadband thanks to this OTT chunk, will be very nice, and it will be done seamlessly without any artifact on the video and easily. And it will be using the same technology that has been implemented on the broadband world, and typically what has been defined by DVB-TA. And for the broadcaster, it will have only one ad advertising system that will be able to cover the broadcast and the broadband network. My last B2C application is mostly the fact that, as we explained previously, DVB NIP is really a file-based content delivery system. We are using it for OTT segment, but we could imagine to use it to push some content on the receiver side or on the home gateway side, to use the gateway at home like edge caching, or to push some video content and to offer like preloaded on-demand content at home to be able to address some receiver or some area which does not have any good broadband connection. And the last is distance learning. We have seen during the COVID-19 that many children were not able to have access to some content for their learning lesson. We could imagine to push this lesson to the home gateway at home and have access with a tablet to this content. So these are some key examples of the B2C market that can be addressed thanks to this DVB NIP technology. I will now give back the head to Emily before Jean-Claude Sachot presentation.
Thank you very much, Richard, for this presentation, and thank you, Thomas, also for the first part. Now, indeed, we can move to Jean-Claude Sachot, who is a Business Development Director for Broadpeak. So he works with global video operators, and he has more than 30 years of experience in the digital video processing and delivery on both engineering and business side. So Jean-Claude, thank you very much. You're also a very involved member with participation in several working groups. So thank you for presenting. Over to you.
Thank you, Emily. So I'm going to start by repeating a little bit what has been said already by others, but as I wanted to pinpoint, by definition of broadcast service is made available to all in the coverage area. The second point, which is important, is that by using file-based video format, the content can be rendered on any consumer device. And by adding local storage capability, the content can be consumed at any time by the consumer. So at the end of the day, by leveraging both satellite distribution and or terrestrial distribution, the native IP broadcast makes video truly ubiquitous. So basically, the content available at any place, at any time, and on any screen. So you're going to say, okay, all right, but is this wishful thinking, or is this really happening anytime soon? So I wanted to share with you some B2B cases that are already driving the market introduction. And I'm introducing here different cases, such as, or pinpointing that there are applications already in in-flight entertainment, in maritime deployments that are already live and running, e-learning programs or applications that Thomas alluded to earlier on, and I will dig into more specifically the AstroCine service. I wanted to say on this slide that this is not just about my company pushing a technology that is already actually proven, but those deployments that I'm referring to here are leveraging different technologies from different vendors. Broadpeak being just one of the companies that has led this transition. So digging into specifically AstroCine, what has been done by Astro to address a challenge that they were facing. You probably, some of you, hopefully most of you know who Astro is. They are the leading pay TV or content provider in their country. This is in Malaysia, so this is mostly a satellite pay TV service first and foremost, but they are also operating an OTT streaming service, which is called AstroGo, and they are enjoying a #1 position on their market. So their question, their problem is how to at least maintain and eventually grow your video audience and revenue where when you're already #1 on your market. And very quickly, they came up with the idea that there is two things that they should be doing. First off, they should extend beyond direct to home to businesses such that they can reach consumers not only in the comfort of their home in front of their TV screens, but wherever they are. And wherever they are means people are spending time in budget hotels, in shopping malls, in retail outlets. So the challenge was to bring the content, the appealing content for the consumer, even in those places. So first idea, leverage businesses. So AstroCine is first and foremost a B2B value proposition. And the second, obviously, is that being a leading content provider with rights on very valuable content, they had to play on their strengths. So obviously, they have a brand which is very known and reputable in Malaysia. They have also content that is very appealing, very attractive. So they came up with a service proposition blending together classic live TV services as well as obviously sport, because sport has to be ubiquitous. And being a satellite pay TV company, obviously, they considered that they could leverage, that they could leverage satellite distribution, because with satellite distribution, they overcome the issue of broadband connectivity in the country, which is not very high in all places where consumers are living. So by leveraging satellite, they plan on making their content ubiquitous. So AstroCine is currently in commercial trial phase. Obviously, this has been a little bit delayed by the pandemic, but the service is already up and running. So how does it work? First, it leverages Astro's existing OTT platform, which is used for the AstroGo internet streaming service that I alluded to already. So basically, as you see on this chart on the top left, there is an existing OTT platform which contains CMS, which contains existing video encoders, and the solution that has been deployed very much materializes all the bricks that have been talked about earlier in the presentation. So there is an origin packager that transforms the video into file segments. Then there is an equipment which converts a unicast stream into multicast, such that it is then modulated for transmission over satellite. And in the business places, there is a receiving equipment, which is a fairly simple satellite demodulation gateway. And that satellite demodulation gateway is meant to receive the satellite signal and distribute it in the business place through the Wi-Fi hotspot that the business owners have in place to distribute it in unicast streaming. So a very regular, very traditional streaming session that takes place between the consumer device that is running the service in the business place and the satellite gateway, which is acting as a local content delivery network. Obviously, this is a tiny CDN, but this is a CDN in full force with a number of similarities and capabilities that we see on regular CDN. Between the business and Astro's infrastructure, there is an internet connection, but that internet connection is not meant to deliver the content. That internet connection is only meant to supervise the good working of the solution. And there is a connection between the satellite gateway and the management platform, which itself is hosted in the cloud. So the management platform is here to enable or to revoke the gateway. And also something of importance is that there is a mechanism which is called the silent login, and the silent login is meant to prevent the users from having to enter credentials to access the service. Actually, the credentials to access the service are the ones of the business owner. So Astro are invoicing the business owner and not the direct consumer. So what are the benefits? The benefits of such a solution for consumers, obviously, the popular live content that they are used to is available anywhere, wherever they go. And this without consuming any of their mobile data plan, because when they are in the premises where the service is available, this is the local infrastructure, the Wi-Fi infrastructure of the premise, which is being used to deliver the service. For the business owner, this is very useful service to make available to customers, because customers stay longer in those places, which is boosting more sales. And obviously, there is no complex infrastructure to be set up other than setting up the satellite antenna and the satellite gateway that I was talking about. And for the content provider, which is Astro, obviously, this makes it possible for them to develop the brand awareness even to consumers that are not subscribing to the Astro Cine service, to the Astro regular service, pay TV service, or Astro Go in Malaysia. This creates obviously good customer stickiness, because when customers are pleased with the service, whether at home or on the go, there is no need for them to consume alternate content. And obviously, in the end, this is generating alternate revenue streams. So moving quickly to the takeaways, as we demonstrate here, the broadcast distribution of OTT format is already field proven and mature. And the proof of that is also for the ones among you who wouldn't know this already, actually delivering native IP content over a broadcast network is already something that is in full force in the ATSC 3.0 standard, and this is already deployed in Korea. So it's not just about DVB dreaming about the future, but actually, as I said earlier on, there are multiple services that are already delivering native IP over broadcast type networks. Obviously, broadcast coverage expands customer reach to all remote places, and also drives OTT streaming costs down, because this is an alternative route for the content, especially the highly popular content. Delivering over a broadcast network is an alternative route to delivering that same content over broadband access. I have presented here a B2B use case, but obviously B2C, so what we call DTH 2.0, can quickly follow B2B if properly planned for. And we are having a number of discussions with regular satellite pay TV operators who have already an installed base of set-top boxes that could support the service by a very simple software upgrade. As we said already, native IP supports numerous other use cases, whether for contribution or for distribution. We already tested that it can be easily transposed to terrestrial, even if I talked about a practical satellite use case. This has already been tested on DTT type networks. And obviously, the only hope that we have for the technology and for the service in future is that DVB standardization is going to fuel the market growth, because we all know that only standards have the power of lowering the barriers to entry for new technologies. And that's pretty much it for me.
Thank you very much, Jean-Claude. Now let's hand over to Thomas again. Thank you.
All right, thank you, Emily. Oh, another mouse click. So now should be in business. What I'd like to do, and thanks to all the colleagues for detailing so much all the aspects of native IP. I think we've hopefully covered every bit of all the pieces. The native IP journey within DVB. As I said, it's a lot about the commercial requirements, and that is in the DNA of the DVB, and I said it before. We in CMS discussed for actually many hours commercial requirements for native IP. Then we detailed them in the document CM 1998, and we grouped them in 7 groups actually. So some very general requirements such as legacy support, the transport requirements, that it shall work via MEO, LEO, GEO, that it also shall support multiple satellite systems, narrowband transponders, wideband transponders, etc., etc. Signaling is the most important aspect eventually. The native IP gateway has to know where to get the signals, to get the content, get all those signaling from which satellite, etc., etc. It's a very complex part in the technical work, I reckon. Content protection, digital rights management, CAS, of course, 2 important aspects. The content delivery, the timeline, that is a bit of a subtle hint to the technical module when the commercial module would like to review a first technical standard. And then last but not least, also we looked at some privacy requirements, so make sure that here for within Europe, it's GDPR compliant what we do, obviously. The work reflects the market needs of the various manufacturers and operators, and you see the logos here of the great contributors in CMS for native IP. And I'd like to thank all of them for their engagement and for the great discussions. And well, I'm sure we have some more once we have the first input from the technical module. The technical specification, and I mentioned the timeline, shall be published by end of 2021. So that is, well, probably more or less ambitious, but there is some time. So who is responsible for the work in the technical module? It's Régis Moulin representing Eutelsat, Tom Christofori representing or working for SES. And there was a new group, the TMNIP group, created for this purpose, co-shared by the 2 gentlemen. And it's quite a big project. And in my last call with Tom, he told me it's well, probably more work than initially thought. Hence the 3 subgroups to support the co-shares here. One working on transport, so ensuring backwards compatibility, core native IP transport, the bonding, etc. Another subgroup on signaling aspects. So this is all the DVB-I signaling, LLC, MABR, all those topics. And also the team found it important to establish a content protection subgroup, because content protection obviously is an important topic, particularly as we, in the commercial requirements, we ask for support of a connected use case and an unconnected use case. So how to ensure content protection in a native IP system in the unconnected use case. So there's some work to be done here. The TMNIP group obviously is liaising with other DVB groups. That's also what we asked in the commercial requirements. We want to see a holistic approach. So they work with CMS, CMSEC, TMI, TMStream, and other groups. And scope is also, of course, not to reinvent a wheel that has already been invented. The promotion of NIP work and its use cases to broadcasters and manufacturers is very important, explaining what we are doing, why we are doing it, And hence again, I'm very grateful to Emily and the project office for calling for this webinar and organizing it today. Right, so with this, I hand it back to Emily, and we come to the Q&A.
Thank you very much, Thomas. And now let's indeed have this Q&A session. So I'd like all the speakers to turn their camera on. And we'll also have an additional person who is Régis Moulin, who is the chair of the technical group in charge of developing the solution. So Régis Moulin works for Eutelsat, and he's co-sharing the group together with Tom Christofori, who cannot be there, unfortunately. But so maybe, Régis, you will have the opportunity to answer one of the questions.
Yes, for sure.
I see one from Peter Sievert, who says that already now with MPE, it is possible to transmit IP over broadcast delivery system. Yeah. So what's the added value of the native IP solution?
Okay, thank you, Emily. Thank you, Peter, for that question, because that helps us just to introduce what is exactly the ambition of a native IP group, actually. And so you are right, MPE is allowed from today, and this actually is a use case which has been presented by Jean-Claude. Is working thanks to MPE, DVB MPE standard. So actually the ambition of native IP is to integrate and to standardize a way and in a transversal way in regards of all these DVB working groups. And so our mission is just to integrate all this technology of IP streaming over broadcast within DVB-I, which is really the center of the strategy of DVB, and with the other technologies as DVB- or DVB MAVR. This is required such kind of standardization is really required, especially because, as also mentioned by Richard, at the end, what we expect is a full convergence between broadcast and broadband. So for this reason, we need to give a proper scope to all actors of the distribution chain to make it happen and to make it work properly. Hope I did answer properly to your question, Peter. But if you don't mind,
so is there anything anyone would like to add on top of that?
Well, Emily, maybe I can briefly give two different aspects. One aspect, when we looked at the cost structure of a mass market gateway device, there was a significant cost saving factor not using hardware that would be used in the context of MPE. Another aspect, I'm not sure what happens if you come to those new LEO operators and you talk about transport streams. So I think here we just have to be much more flexible, but much more versatile, as Régis said, and make sure that native IP can seamlessly fit into all those new environments. That is very important.
Thank you, Thomas. I have a question now, maybe for Richard. So it's about the overall service quality. So the question is, how can one guarantee an adequate video and audio synchronization when using broadband delivered audio while video is on broadcast? And also what hardware buffer is needed on the receiver side?
That's a very interesting question. The fact is the way the content is delivered in the broadband world and will be the same in DVB and IP is exactly the same. So the synchronization between the audio and the video should not rely on the network itself. The only issue that we can face is the delay, which could be different between the content which will be received over broadcast and the content which will be received on the broadband part. But the synchronization itself should be done by the encoding side and the timing information which are inserted on the dash segment and the segment number or the time number of the segment. So the synchronization is made at the encoding side. The only thing that we have to be sure that if we have content providing delivering over broadcast and content delivering over broadband is that we have enough let's say, buffer or enough synchronization to be sure that one segment will not arrive in advance compared to the other one, but the synchronization itself is done at the video and audio compression. So that's a network issue for the managing of the delay inside the different delivery chain, but the synchronization is not, let's say, done by the network, but done by the encoding part.
Thank you very much, Richard. Another popular question is about how many dash profiles are transmitted, and is there any given time? I don't know who would like to answer that.
Yes, I can.
Yes, please.
Okay, so about how many profiles or representations that could be broadcast, it really depends on the use case, actually. For the B2C use case, we expect, we are in a quasi-error-free environment to receive the TV as today, actually. So for sure, it would be not necessary to have several representations of the same service. But for other kind of use cases for B2B, as for example, the one for the hotspot as presented by Jean-Claude, or for delivering, I would say, or feeding, I would say, a 5G cell tower, it could be useful to have several of them. And because after the usage of this representation would be done for the network itself and should comply to the constraint of delivering content over Wi-Fi or over 5G. So actually, there is no limit about this.
Indeed, thank you very much. There's another one which is, I think, quite popular, which is there foreseen terrestrial IP within DVB? So I may take that one personally in the name of DVB. So indeed, there is not a DVB working group in charge of the native IP solution for terrestrial networks for now. And this is mainly because the satellite stakeholders were the first one to really have a need in that regard. However, the terrestrial broadcasters indeed already showed some interest in the solutions. There's TDF in France, for instance, and other ones also in Australia and more, of course. But for them, I think that this needs of a unified system is more for the long term. So there is, I would say, less urge in doing so right now for them. And also, I think it's important to say that the work which is being done today in the native IP group with the satellite mainly use cases, even if it's not only satellite use cases, this work is intending to be network agnostic. The choices are made at least to that extent, and there's also how to say. So yeah, today the choices are made in order that the solution will work on terrestrial, and this is especially relevant because this is DVB's, as I said in the beginning, DVB really want to deliver a whole package that would enable a seamless user experience, and there is no reason why we could not be able to receive OTT streams to satellite and not through terrestrial. So this is being done, even if it's today in a group which is mainly gathering some satellite requirements. But we have in mind, of course, that the same will be done for the terrestrial networks. So maybe we can handle a very last question, which is a question from Gert. And this one is about, so it's quite long, acknowledging the statement that the increased linear TV watching, there's an increased trend to watch TV on linear due to the pandemic. There's also a trend to move linear channels to an OTT silo. So how do you envision the DVB ecosystem, and especially with native IP, to support this trend? And he gives the example of Disney Plus, who announced the close of 100 international TV channels by the end of the year to move them to Disney Plus. So originally it was a question for Thomas. I don't know, Thomas, if this, if you would like to answer this.
No, fine. It's a great question that Gerd is asking, and we've been discussing this a lot, be it at the satellite operators' premises or in the DVB. It also, the whole thing depends also on the business model. I mean, today a lot of these big streaming providers, and the Amazon MGM case is about having additional content for the streaming use case. Is they are focusing on the markets where Wi-Fi or high-speed internet is more or less omnipresent or getting omnipresent. So the question we really have to ask to those streaming providers, hey guys, what about business cases in remote areas? How reaching consumers on ships, etc. And I think once that question is answered, then we realize that with native IP and the combination of broadband and broadcast, the use case can be much better supported as today. That's simply my answer in that case.
Thank you very much, Thomas. And this was actually a question from Alan, not Gerd, and I should have recognized his style. Sorry for that. So thank you very much to our audience also for attending this webinar. I will close it now. We are now over time. So a great thanks to our speakers today. I think you really managed to show that this native IP solution will offer really new business models. It will unify the platforms and etc. So thank you very much for that. And thanks to our audience. And please don't hesitate if you have any further questions, because I acknowledge that we have not answered to all of them. So you can reach out to DVB and to the speakers so that your questions can be answered. Thank you very much. Bye.
Thanks. Bye-bye. Thanks, Emily.
Thank you. Bye.